Hi, I'm Dave Kassler, KE0OG, with episode 64, and we're talking about the MFJ High Q magnetic loop, the one designed to go from 40 meters to 15, and it's designated the MFJ-1788. And in the last video, we looked at it, and I put it up, and it was great on 20, but had issues on 40. So I got lots of comments. Thank you for all the many comments I got back, including some I'm going to show you a little bit later in the show from some one of the viewers who had put this thing into his attic and it worked very successfully on 40 meters. So what I tried to do was to take that steel pole out of the mounting system and just mount the board directly to the antenna and put it up. The answers weren't really good. Didn't really affect the problem, but I'll just show you a little bit of what I did to give it a try. So what I'm doing with this video is asking you for your input and your ideas on how this antenna can be fixed. I've heard from many of you that yours works really well on 40. I have to admit being slightly jealous. So do please tell, and we'll see what we can do to develop a conversation here for this. By the way, there's a program on Tuesday nights at 8 p.m. Central, 7 p.m. Mountain Time, put on by W5KUB.com. And in this, Tom Medlin interviews a bunch of people, and I've been on that show several times here recently. So that's Tuesday evenings at 7 Mountain or 8 Central, 9 Eastern, 6 Pacific. Give it a try. See what's available there. I also heard from MFJ today. They saw the video on the antenna and thought it was a good video, so that's great. I will get this thing working. It will work. I have lots of MFJ equipment, and mostly it works just fine, but I'm having a particular problem with this one right now. So let's dive in and take a look at how I took the steel pole out and put it up on a piece of wood. And then let's look at the photo sent to us by a viewer, and then we'll outline what my next step is going to be, how I'm going to add some capacitance to this thing. I have an idea for doing it without having to open it up. We'll see if it works. Ready? Here's the antenna laid out on the back porch there. I've disconnected the steel bar that went between the wood and the mount, and am ready now to trace out the pattern on the piece of wood. Looking down at the antenna, you see those 4 holes at the bottom. That's where the main connection is for holding the thing up. That is actually goes into an aluminum plate that's welded or heliarced to the loop itself. So it's actually electrically connected to the loop. Also inside that box there is the coupling loop. This is a close-up of the holes. You see that the holes have been threaded inside that piece of aluminum there. This piece right here is part of the mounting in case the antenna is mounted horizontally. Since it goes right in those 4 holes, I can use this as a pattern for the holes. Here I have sketched out just where those holes are, and the next step is to drill them. I am a notoriously bad driller. I have no idea what vertical is, so we're going to have to do this kind of iteratively to make it work. Let's see if I can do this here. Let's see how well we did.
Is there sound on this?
Yes, there's sound on that. Tell you what, why don't we stop filming so you can give me a hand? Okay, so here it stands in this wide-angle photograph with the Snuffles Range in the background and the trees near our house standing up there, and you can see that it is connected just to the wood. The wood goes straight into those 4 mounting holes. This is a close-up. It's not as badly misaligned as it looks. Those brackets there have slots in them rather than holes, so they're a little bit sideways, but everything actually still works. So we got the antenna up and ready to do some test measurements there. All right, here we are. We've got this thing pushed down. It's gone down all the way it can go down. All right, and we find out what frequency it goes to when it goes down. 7.241, which was essentially the same as before. It's a few kilohertz different. And the best SWR that we can get in here, and it's really touchy, is about 1.8, which is going to make the 2 SWR curve a little bit difficult to find. So we've not made any progress mounting it just on the wood, so we're going to have to look at something else. Viewer Peter Straticus AC4PS has had good luck with this antenna, and I asked him to send me some pictures of his installation. This is actually an attic antenna. So we see here the plastic base. It goes out 4 different ways, so it's something for the antenna to sit on, and it's connected right up there. Now initially he had a problem with this being oriented sort of north and south only. Through the center it has a dead spot, so it tends to go off the ends of the loop, but there's a dead spot in the middle. This picture shows the entire thing. It's not actually attached to the house anywhere. It sits on that stand. Now, he found that in order to avoid that dead spot, he decided to put it on a rotator. So this is what he did prior to putting it up in the attic there. There's a rotator clear down at the bottom, and then again the plastic shaft up there, and that will rotate the whole antenna, and that way he can move his signal and avoid the dead spot there. It's mounted to a plexiglass bottom there, and those are felt pads to keep the vibration of the rotor from coming back down into the house. And he's had outstanding luck with this antenna and finds that his 2 dB bandwidth on 40 meters is closer to 20 kilohertz. So looking closely at those photos and appreciate it. And if anybody else has photos, do please feel free to send those along. Simply go to DCasler, that's DCasler.com/ask-Dave, and send something to me, a comment or something, and then I'll reply to that, and then you'll have my email address. Now let's look at what we're going to do for the next time. This is a picture of my Butternut HF9V. It's a multiband antenna, and rather than traps, employs some tuned circuits. You can see the coil. That's obvious what it is. What isn't obvious is that piece of metal sticking out to either side is electrically a capacitor. Now, it's capacitance we need to increase on the MFJ loop antenna, so I'm going to try attaching a strip of metal to the antenna toward the top on either side of the capacitor to see if that might increase the capacitance. Now, there are also available these little capacitors that are very high voltage capacitors used in this antenna so that they didn't have to use traps. That way there's less energy lost in the traps. One thing that I did discover that was growing out amongst my antenna radials was the first flower of May. So we gave the antenna a try, and it didn't work. Nothing changed. It worked the same way as it had before, so the approach that we used did not solve the problem that we had on 40 meters. Please, if you have some thoughts, send comments, suggestions, pictures, whatever it might be. I am going to stay with this until I get it fixed. Until next time, please use both feet when walking. Click on like and click on subscribe. Check out the tip jar and the Patreon page. Until next time, 73.
Okay?
Yep, okay.